I'm going to show you how to graph a quadratic function or a parabola that's in standard form. Standard form is a quadratic equation that's basically multiplied out, so it's in this format: y equals ax squared plus bx plus c. In that format, you do have some information before you even start. The a value is the same a value that lets you know if it's vertically stretched or if you have a vertical shrink of the parent function. And the c value is the y-intercept, where it crosses the y-axis. Just from that information, you will definitely get a start to how to graph it. I'm going to go ahead and do the first problem. So first of all, I want to write the vertex down, the a value. I'm also going to write the axis of symmetry and the y-intercept. As we start, the coefficients are a, b, and c. C is the y-intercept, so I'm going to go ahead and write that down. The y-intercept is 2, so I already know that my parabola crosses the y-axis at 2. The a value is 2, which means that since it's positive, this parabola is facing upward. And since it's 2, it's twice as tall as a normal parabola. To find the vertex, there are a couple ways of doing this, but the first step is always the same. In order to find the x value, you must use the formula negative b over 2a. So negative b would be a negative 8, or the opposite of negative 8, which is 8. And then the denominator would be 2 times the a value. So we have 8 over 4, which is 2. That is the x value of the vertex. It is also your axis of symmetry. So you can go ahead and dash that into your problem. So your parabola, half of it will be on the right of that line and half of it will be on the left of that line. In order to find the y-intercept, you can do this by looking at the graph at this point. We have a point at the y-intercept. We definitely have to have a point exactly the same place on the other side of that axis of symmetry. I also know that the y-intercept is 2 units away from the axis of symmetry. Since this parabola is going up, that means my vertex has to be down in this area. I need to figure out how far down it needs to be. If I were going from the vertex up to the y-intercept, since it's 2 units away, let me erase that. Since it's 2 units away from where the vertex would be, I would have to go up 8 units because that would be 2 squared, which is a normal parabola would be 2 squared. And then I would have to multiply that by the a value, which is 2. So if I wanted to go back down from the y-intercept to the vertex, I could go over 2 and down 8. 1, 2, 3, 4, 5, 6, 7, 8. And that would give you your vertex. Now, if you want to do this mathematically, that's always an option. So we would write the original equation, 2x squared minus 8x plus 2. And we're going to plug in this 2 for all the x values. We work out 2 squared minus 8 times 2 plus 2. Don't forget, you must square before you multiply by 2. So that's going to be 2 times 4 minus 16 plus 2, which is 8 minus 14, which is negative 6. So this is the y value of the vertex, which I've kind of already shown you. But if you don't know how to figure that out by going backwards, again, that's over 2, 2 squared times a is 8. Instead of going up, we must go down because the vertex has to be below because this parabola is going up. I want to plot a few other points now. So again, because a is 2, we're going to go right 1 and up 1 squared times 2. Over 2, 2 squared times 2, that's 8. And if I was going to go over 3, remember, these are your normal y values. Okay, and then we're starting again. This is like my new origin here. I guess I should dash that in. Pick the wrong color here. Okay, here we go. And so I have to go twice as many as these because A is 2. So 2 times 1, 2 times 4, 2 times 9, 2 times 16. So the next point over would be 1, 2, 3. That's 3 squared is 9. 9 times 2 is 18. So 18 up would put me at 12, which is pretty far up there. Since it's off the graph a little bit, you can just connect these. And then that's how you do that.